Okay, today we're going to discuss derivatives of exponential and logarithm functions or logarithmic functions. According to this, we have a theorem 5.3, derivative of the natural logarithmic function, let u be a differentiable function of x. So the first formula, the derivative of ln of x is equal to 1 over x, provided that x is greater than 0. The second one, the derivative of ln of u, so is equal to 1 over u times the derivative of u, which is the du over dx, is just equal to u prime over u, or du over u, where u is greater than 0. And we also have the derivative of e raised to x is just equal to e raised to x. And the derivative of ln of x can be written as 1 over x. And the derivative of a over x, where a is a constant. So the derivative of that is equal to a raised to x ln of a. And the derivative of the logarithm of x to the base a is equal to 1 over x ln of a. So I guess this second part is just the same as this. Okay, we have according to the theorem 5.11, so derivatives of the natural exponential function. So let u be a differentiable function of x. So this is what I'm trying to say a while ago, that the derivative of e raised to x is equal to e raised to x, and the derivative of e raised to u is equal to e raised to u, and then take the derivative of the exponent of u, which can be written as du over dx. And another formula for the derivatives for bases of other than e. So we have let a be a positive real number where a is not equal to 1, and let u be a differentiable function of x. So the derivative of a raised to x is equal to ln of a times a raised to x. And number 2, the derivative of a raised to u is equal to the ln of a times a raised to u times the derivative of the new exponent, which can be written as du over dx. And number 3, the derivative of the logarithm of x to the base a is equal to 1 over ln of a times x. And number 4, we have the derivative of the logarithm of u to the base a is equal to 1 over ln of a times u times the derivative of u, which is can be written as du over dx. Okay, so let's try some exercises. So letter A, find the derivative of ln of 2x. So to use that one, we are going to use our formula. Okay, so the derivative of ln of 2x can be written as 1 over 2x times the derivative of 2x. So I'm just showing that we are going to take the derivative of the angle of the ln of the angle for the ln is 2x, which have the derivative of 2x. So taking that one, we have 1 over 2x times the derivative of 2x is equal to 2. Therefore, the answer now is 1 over 2x times 2. So 2 there will be cancelled. So therefore, the answer is just 1 over x. So that is now the derivative of ln of 2x. And for letter B, we have the derivative of ln of x squared plus 1. So this can be written now as 1 over x squared plus 1 times the derivative of x squared plus 1. So simplifying that one, so we have 1 over x squared plus 1 times, we are going to take the derivative of x squared plus 1, which is now 2x, then multiply. So this can be written now as 2x over x squared plus 1. So in that case, class, we cannot cancel x here because this one is monomial, and the denominator here is a binomial, so we cannot cancel the x. So therefore, the answer is 2x over x squared plus 1. Now for letter C, we have the derivative of x ln x. So in that case, we are going to use the product rule. So the derivative of this will become x times the derivative of ln of x is 1 over x plus the second term, which is now ln of x, times the derivative of x is equal to 1. Now simplifying that one, x times 1 over x is 1 because x over x will be cancelled. So we have now 1 plus ln of x times 1 is just equal to ln of x. So the derivative now of x ln x is equal to 1 plus ln of x. And for letter D, we have here the derivative of ln of x. The quantity of ln of x is raised to the power of 3. So first, we are going to apply the power rule. So this can be written now as 3 ln of x times the derivative of ln of x. So therefore, we can write as 3 ln of x times the derivative of ln of x, which is equivalent to 1 over x. So multiplying that one, 3 ln of x times 1 over x can be written now as 3 over x of ln of x. Go for the next example, we have r of w is equal to 4 raised to w minus 5 logarithm of w to the base of 9. So the first term can be written as the derivative of that will be equal to, so using the formula, we can write now as ln of a. Our a there is 4, so we can write now ln of 4 times the given is 4 raised to w, 4 raised to w times the derivative of the exponent. So d over dw of w. So later on, we're going to simplify that one. So let's move on first, the second term. So we have the negative 5 logarithm of w to the base of 9. So according to the formula, we are going to write first as negative 5 times 1 over ln of 9 times w, and then take the derivative of u. So d over dw of w. Okay, so simplifying this, we can write now as ln of 4 times 4 raised to w times the derivative of w is just equal to 1 minus 5 times 1 is 5 over ln of 9 of times w times the derivative of w is just equal to 1. So therefore, the final answer now will be equal to ln of 4 times 4 raised to w minus 5 over ln of 9 times w. So, okay, for you to be properly guided, I require you to write the formula. So our formula for that will be equal to d over dx of the logarithm of u to the base of a is equal to u prime over ln of a times w. So that is what I am following to solve for that, for the second term. But for the first term, so you just follow the formula of uh, the second term, we have derivative d over dx. So this is the formula to be followed in the first term. We have the derivative of a raised to u. So that can be equal now to ln of a times a raised to times u prime. Okay, so that's the formula that I use. So try to see this one. The first term we have 4 raised to w. So I'm using this one. Our a there is 4 and our u is w. So this therefore it can be written as ln of a times a raised to u times the derivative of the exponent, which is now the u prime. So this is what I did. So ln of 4, ln of the base times the given 4 raised to w, then derivative of the exponent of w is just equal to 1. That is why you can write down there as ln of 4 times 4 raised to w. Okay. Or you can write as well as 4 raised to w times ln of 4. So it is commutative. we can apply commutative property. And also for the second term, I'm using the formula of the logarithm of u to the base of a is equal to u prime, the derivative of u, of the derivative of ln of a times w. So we have here, since there's a coefficient of 5, so I write 5 times, I take first the reciprocal of this, so 1 over ln. So if you're going to write in a fraction form, instead of writing logarithm, you are supposed to write 1 over ln of the base, which is 9, and then times the angle, which is w, times the derivative of the angle, which is w. So derivative of w is 1. So that is why we have the final answer now of ln of 4 times 4 raised to w minus 5 over ln of 9 times w. Or you can write this one. Okay, in some other books, they are used, instead of using this answer, they are expressing their answer in terms of 4 raised to w times ln of 4 for the first term, minus for the second term they write as 5 over w times ln of 9. So they are just the same. So we know that multiplication is observing the commutative property of multiplication. Now for the next number, we have f of x equals 3e raised to x plus 10x cubed ln of x. So to solve for that, so we have f prime of x is equal to 3e raised to x. The derivative of e raised to x is just the same as e raised to x if the exponent of x is only 1. But if the exponent of x is not 1, then you have to take the derivative of the exponent. So in that case, we only have 3e raised to x plus we have now, we are going to apply here the product rule. So I will write first the coefficient of 10 times, using the product rule, I can write now x cubed times the derivative of ln of x is 1 over x plus ln of x times the derivative of x cubed is 3x squared, and then simplify. So we can write now as 3 e raised to x plus 10 times, so simplifying inside the bracket, x cubed times 1 over x, so give us the answer of x squared plus ln of x times 3x squared, so I can write the answer as 3x squared ln of x, and then multiplied by 10, so therefore we have 3e raised to x plus 10x squared plus 10 times 3 is 30, so we have 30 x squared ln of x. So that is now the derivative, the given function. So for this, we have y equals 5e raised to x over 3e raised to x plus 1. So in this case, we are going to use the quotient rule. So if this is my u and this is my v, then I will use the formula of v du minus u dv all over v squared. So y prime now is equal to this formula. So by substitution, I can write first the v. We have 3e raised to x plus 1 times the derivative of the numerator, which is 5e raised to x. So the derivative of that is just the same as 5e raised to x minus, copy first the numerator, which is the u. We have 5e raised to x times the derivative of the denominator. So the first term is 3e raised to x. The derivative of the first term of the denominator is 3e raised to x, and derivative of 1 is just 0, then don't need to write 0, all over the square of the denominator, which is now the square of 3e raised to x plus 1. Now simplifying this one, so we can write now 3e raised to x plus 1 times 5e raised to x. So this can be now 3 times 5 is 15. And apply, since multiplication, e raised to x times e raised to x. So the answer is e raised to 2x, because we are going to add the exponents. So plus, we have 1 times 5 e raised to x. We have 5 e raised to x minus this one, also the product of that becomes 15 e raised to 2x all over 3 e raised to x minus 1 to the power of 2. So since we have similar terms, so we have 15e raised to x and 15e raised to 2x, and they are additive inverse. So therefore, that can be cancelled. So our final answer now will give us 5e raised to x over 3e raised to x minus 1 to the power of 2. Sometimes the task of finding the derivative of a complicated function involving products, quotients, or powers can be made easier by first applying the laws of logarithms to simplify. So this technique is called logarithmic differentiation. So let us take a look at this example. So we have f of x equals x times 3x minus 1 times x squared plus 3 is given. So find the first derivative of f by using logarithmic differentiation. Now to solve for that, we are going to take the logarithm or ln of both sides. So therefore, I can write now as ln of f of x is equal to ln of the right side, of the right hand side. So I can write now ln of x times 3x minus 1 times x squared plus 3. Now, so as you can see there, I only write ln both sides of the equation. Now, after that, we are going to expanding the right hand side. So we can write now as ln of f of x is equal to ln of x plus ln of 3x minus 1 plus ln of x squared plus 3. So from a single term, I used the properties of logarithm. So I expanded that one in terms of ln of x plus ln of 3x minus 1 plus ln of x squared plus 3. Then after that, we are going now to take the derivative of both sides. So taking the derivative of ln of f of x, that can be written now as we have 1 over f of x times the derivative of f of x is equal to f prime of x is equal to the derivative of the right hand side. So we're gonna take the derivative of each term. So derivative of ln of x is equal to 1 over x plus the derivative of ln of 3x minus 1 is equal to 1 over 3x minus 1 times the derivative of 3x minus 1 is equal to 3 plus derivative of ln of x squared plus 3 is equal to 1 over x squared plus 3, and then take the derivative of x squared plus 3. So simplifying this one, 1 times f prime of x over f of x can be written as f prime of x over f of x is equal to, so 1 over x plus we have the derivative of 3x minus 1. The correction for this, so I am showing it first, the derivative of 3x minus 1. So instead, I supposed to write there as 3x minus 1. Now, taking the derivative of that now, so I can write now as 1 over 3x minus 1 times derivative of 3x minus 1 is 3 plus the second term is 1 over x squared plus 3 times the derivative of x squared plus 3 is 2x. Now simplifying further, so we can write now as f prime of x over f of x is equal to 1 over x plus 1 over 3x minus 1 times 3 is equal to 3 over 3x minus 1, and 1 times 2x is equal to 2x for the numerator, and copy the denominator of x squared plus 3. Take note, we are about to find the derivative. So we are going to solve for f prime of x. But we have here f of x in the denominator. So therefore, I will multiply the entire equation by f of x. So if we are going to multiply the entire equation by f of x, so this becomes now I write the answer on the right hand side. So this becomes now, the right hand side becomes f prime of x is equal to f of x times whatever in the right hand side. So I can write now 1 over x plus 3 over 3x minus 1 plus 2x over x squared plus 3. Now, f of x is actually the given. So by substituting back the meaning of f of x, so therefore f prime of x is equal to x times 3x minus 1 times x squared plus 3, and then copy what is inside the bracket. So I will write that one as 1 over x plus 3 over 3x minus 1 plus 2x over x squared plus 3. Now, we can write f prime of x is equal to, you need to multiply the value of f of x, which is these three terms, times whatever inside the quantity in the bracket. So, we have to multiply. So, x times 1 over x, it gives us now the answer of 1. So the answer in the first term becomes 3x minus 1 times x squared plus 3. And then on the second term, so the value of f of x, which is this one. So in the entire of this is the value of f of x times the second term, which is 3 over 3x minus 1. So we can cancel 3x minus 1. And we have the remaining answer now becomes plus, for the second term, we have plus 3x times x squared plus 3. And then the third term will be plus, I will write it down. So we have the value of f of x, which is this one that I underline, times 2x over x squared plus 3. So I can cancel the x squared plus 3. And the remaining now is x times 3x minus 1 times 2x. So if you're going to multiply x times 2x, the monomials, we have x times 2x is 2x squared times 3x minus 1. So I will just rewrite it here to expand our final answer. So we have f prime of x is equal to 3x minus 1 times x squared plus 3 times 3x times x squared plus 3 plus 2x squared times 3x minus 1. I have plus here. Okay, the second term, it would be okay if you're not going to use distributive property, but if you want, we can do it further. So our answer now becomes 3x minus 1 times x squared plus 3, and then the second term will be plus multiplying that one using distributive property. So 3x times x squared is 3x cubed plus 3x times 3 is 9x plus the third term now is using distributive property. So we can write now as 6x cubed. Then 2x squared times negative 1 is negative 2x squared. Now, if you want to simplify further on the first term, we can write now as, so using distributive property or FOIL method, so we can write 3x times x squared, we can write now as 3x to the power of 3. And then 3x times 3 is plus 3x. Outer terms, we have negative x squared. And negative 1 times 3 is negative 3. And I will copy the rest of the terms. But I guess we need to combine like terms so that we will not write a very long answer. So we can write now as 3x cubed plus 6x cubed is equal to 9x cubed. Then plus 9x minus 2x x squared. Now, so we can see that there are still like terms. So combining like terms now, we can write our answer as 3x cubed and 9x cubed are like terms, as well as the negative x squared and the negative 2x squared. So combining like terms now, 3x cubed plus 9x cubed equals 12x cubed. And then in terms of x, we also have 3x plus 9x, so plus 12x. And then negative x squared and negative 2x squared, so negative 3x squared, negative 3. So that will be now our final answer of f prime of x. But actually, class, it would be okay for me. So I will accept your answer up to this point, to present your answer up to this point, so that we will not be dealing too long in simplifying the algebra. Okay, next one is find the derivative of the function of f of x equals x to the power of 3/5 times the cube root of x squared plus 1 all over 2x plus 1 to the power of 7. So if you see that the given is quite complicated, then the best way to solve for that is using the logarithmic differentiation. So I'm going to take ln, or the logarithm, on both sides. So I can write now as we have ln of f of x is equal to ln of the given, which is x to the power of 3 over 5 times the cube root of x squared plus 1 all over 2x plus 1 to the power of 7. Okay, so after that, we are going to expand our right hand side. So I can write ln of f of x is equal to ln of x raised to the power of 3/5 times, so it's multiplication, we have to write plus. So ln of the cube root of x squared plus 1. Since this is in the denominator, so we can write now as minus ln of 2x plus 1 to the power of 7. Now after that, we are going to take the derivatives. So the derivative of ln of x is equal to 1 over f of x times derivative of f of x is equal to f prime of x is equal to, we have the derivative of this, we have 1 over x to the power of 3/5 times the derivative of x to 3/5, we have 3/5 of x to the power of 3/5 minus 1 becomes negative 2/5 plus, so we have ln, so I can write now 1 over uh, the cube root of x squared plus 1 times the derivative of your denominator can be written as 1/3 times x squared plus 1 to the power of, so we subtract the exponent of 1/3 minus 1, that is now negative 2/3 minus, we have 1 over the derivative of ln of 2x plus 1 to the power of 7 is equal to 1 over 2x plus 1 to the power of 7 times the derivative of 2x plus 1. So power rule. So derivative of the denominator now using power rule, we have 7 times 2x plus 1 to the power of 6. And then we have the derivative of 2x plus 1 is equal to 2. So actually, I am introducing to you the chain rule. So in chain rule class, so first you're going to take first the derivative using the power rule, and then after that, you take the derivative of the angle. So it happened that the angle now is 2x plus 1, so the derivative of 2x plus 1 is equal to 2. Okay, now simplifying that one, we can now write as f prime of x over f of x is equal to, so simplifying this one, so we have 3/5 of, we have here x to the power of negative 2/5 over x to the power of 3/5. So they are the same base. We are going to subtract the exponents. To simplify for that, we can write now negative 2/5 minus 3/5. So we have negative 2 over 5 minus 3 over 5. So the exponents now will give you negative 1. So we can write now x to the power of negative 1. So plus, so when you solve for this, we have 1 times 1/3. So I can write now 1/3. And then, so this is now the denominator of the cube root of x squared plus 1. So they have the same base of x squared plus 1. So the same manner, we are going to subtract their exponents. So the exponents now we have negative 2 over 3 minus the exponent now here in the cube root becomes 1/3. So the difference now between the two is negative 1. So I can write now the quantity of x squared plus 1 to the power of negative 1. So minus on the third term, so we have here 7 times 2 times 1. We have now 14. There's a negative sign, so right there 14. So the base is the same. We have 2x plus 1 and 2x plus 1. So we are going to simplify. So we have now a denominator of 2x plus 1 to the power of 1. So no need to write the power of 1. Okay, so we can write now, we simplify further. So we can write now f prime of x. So we have f prime of x over f of x is equal to 3 over 5. So I rewrite in terms of positive exponents. So the x will go together with with 5 plus this one now will become 1 over 3 times the quantity of x squared plus 1 to avoid negative 1 exponent to the binomial minus 14 over 2x plus 1. Now this is similar to our previous example. So we can now multiply the entire equation by f of x. So multiplying that one, it gives us now the answer. This is our continuation. Okay, so we can write now f prime of x is equal to f of x times the quantity of 3 over 5x plus 1 over 3 times x squared plus 1 plus minus we have 14 over 2x plus 1. So that's 14. So by substitution, we can rewrite the meaning of f of x, which is the original given. So therefore, we have f prime of x is equal to x to the power of 3 over 5 times the cube root of x squared plus 1 all over 2x plus 1, the quantity of this raised to 7 times 3 over 5x plus 1 over 3 times x squared plus 1 minus 14 over 2x plus 1. Okay, so for you not to have a very long solution, so you can end up your answer up to this point. So no need to simplify because it will take a very long solution using simplification of algebra. So it's enough up to this point. Okay, so the next examples here is in terms of taking the derivative of exponential forms. So I have shown to you a while ago the formulas of the exponential forms like this. So we're going to use that formula to solve for the following problems. So the derivative of e raised to 2x minus 1. So to solve for that, so the derivative of this is that we have e raised to 2x minus 1 times the derivative of the exponent, we have 2x minus 1. So simplifying that one, we can write now e raised to 2x minus 1 times the derivative of the exponent, which is 2x minus 1 is just equal to 2. Therefore, the derivative of that now, it gives us the product of 2e raised to 2x minus 1. So that's the derivative for that. For number 2, we have the derivative of e raised to negative 3 over x. So in similar manner, I can write now as e raised to negative 3 over x times the derivative of the exponent. We have negative 3 over x, or negative 3 over x can be written as, we'll just rewrite this one, negative 3 over x times the derivative of this. So another way of writing the negative 3 over x can be written as negative 3 times x to the power of negative 1. Now, it's easier for us now to take the derivative. So using power rule, so we can write now e raised to negative 3 over x times negative 1 times negative 3 is positive 3, x to the power of negative 1 minus 1 according to the power rule. This becomes now negative 2. So multiplying that one, so the answer now will become 3 over x squared times e raised to negative 3 over x. So this is now the derivative for that problem. So next we have y is equal to 2 raised to x. Okay, so what's the derivative of that? We are using here the formula for d over dx of a raised to u, where a is a constant and u is your x. So according to the formula, so the derivative of that will be, we have ln of a times the given of a raised to u times u prime. So using that formula, so we can write now y prime is equal to ln of the base, which is now 2, times, copy the given of 2 raised to x, times derivative of your exponent, because u here is the exponent in our formula and the derivative of x is just equal to 1. So 1 there is equivalent to u prime to that formula. So simplifying that, we have now y prime is equal to 1 times ln of 2 is ln of 2 times 2 raised to x. Some authors represented this answer in this form. They are just going to interchange the answer. Sometimes it is 2 raised to x, then ln of 2. So actually, they are just the same. Okay, now next is y is equal to 2 raised to 3x. So you are going to use the same formula. So they differ only in terms of the exponents. So therefore, y prime is equal to, we have ln of the base. So the base is 2. So we have ln of 2 times, copy the given. We have a raised to u. We have 2 times to the power of 3x times the derivative of the exponent, to take the derivative of the exponent, which is 3x. So therefore, we have ln of 2 times 2 raised to 3x times the derivative of 3x is just equal to 3. Then multiply the monomial. So therefore, ln of 2 times 2 is equal to 3 ln of 2 times 2 raised to 3x. So you cannot multiply 3 times 2 from the base of 3x. That is not equal to 6 to the power of 3x. So the correct way is that you multiply 3 to the ln of 2. Then it becomes now 3 ln of 2 times the given, which is now 2 to the power of 3x. Now, the next example, the given is y is equal to the logarithm of cosine of x to the base of 10. Now, in that case, we're going to use our formula. So our formula for this is equal to, I will write first the formula, the derivative of logarithm of u to the base a is equal to u prime, which means the derivative, all over ln of a times the angle u, or times u. So using this formula, we can now write our answer. So we have y prime is equal to u prime. So I can write first 1 over ln of the base, which the base now is 10. So ln of 10, all right, times the value of u now in our given is cosine x times the derivative of the cosine x. So if we are going to take the derivative of that, that becomes now the value of u prime. So therefore, y prime is equal to 1 over ln of 10 times cosine of x times the derivative of cosine x is negative sine x. Okay, so simplify that one. So 1 over ln of 10 times cosine of x times the negative sine x in the numerator. So multiply, it becomes now negative sine x over ln of 10 times cosine of x. But what is ln of 10? So ln of 10, if you're going to use your calculator, it will give you a decimal number. So therefore, just remain as ln of 10. So what we need to do to simplify is we are going to take the identity of sine x over cosine x. So we know that the identity of sine x over cosine x is tangent x. So finally, our answer becomes the negative of tangent of x over ln of 10. So that is now the answer for that problem.